Hello viewers and all the learners. Welcome to Unacademy YouTube session. Myself Vetrivel, Unacademy Plus Educator. The best plan for Karnataka Common Entrance Examination 2021 aspirants. The India's topmost online coaching and teaching platform, Unacademy. The comprehensive batch and champion batch is on live for complete syllabus coverage, right? Everything affordable price. So all the viewers, especially those who are preparing for all the competitive examination, especially Karnataka CET, JEE, NEET, it is the wonderful opportunity for you people to secure good rank in CET. So unlimited access for a single subscription. Batches for complete preparation is going on. So join, subscribe Unacademy, use my code VETRILIVE. And today's session, I'm going to bring you the important MCQs in radioactivities, right? So let us begin today our topic and session, radioactivity. We all know the spontaneous emission of radiation of those substances whose atomic number more than 82, heavier nuclei, they are unstable, so they emit spontaneously to in order to become stability. That is the spontaneous emission of radiation by heavier element. Generally we call it as radioactivity. Radioactivity was discovered by Henry Becquerel, right, in uranium salt in 1896. All the elements with atomic number greater than 82 are radioactive element. Some example we all know: uranium, radium, thorium, polonium, protactinium, neptunium. These are all radioactive elements whose atomic number greater than 82, having unstable nuclei. In order to acquire stability, they go on to emit radiation, right, in the form of alpha, beta, gamma rays, right. Pierre Curie and Madame Curie, right, after Becquerel discovered uranium, these two, Madame Curie and Pierre Curie, discovered radium. This radioactivity of radium is 10 power 6 times more than radioactivity of uranium. Radioactive decay law. This is most important here. We are going to solve the MCQ based on these formulae. Just try and bring to your notice. Just recollect it. We all know the rate of disintegration. Radioactive decay law says dN by dt. The rate of disintegration is directly proportional to number of atoms present at that instant of time. So dN by dt proportional to n. Dn by dt equal to minus lambda n, where lambda is decay constant, where n naught, number of atoms present initially when t equal to 0, before it start to disintegrate, right? N naught is the number of atoms present initially. After once it started to disintegrate, radiation, right, radioactivity, one particular instant of time, what is the number of atom undecayed? That is n. N naught is initially, if I take uranium or radium, radioactive substance, before it start to disintegrate at t equal to 0, initially the number of atom present in it, n naught. After particular time, after it is it's going on process, radioactivity process, emission, at particular instant of time, what is the number of atom left over undecayed? That is n. So dN by dt, rate of decay, and lambda is decay constant, we know. SI unit of radioactivity, we all know that Becquerel. Other units are Curie and Rutherford. 1 Curie equal 3.7 into 10 power 10 Becquerel, right? We all know that half-life period, right? The half of the original atom to disintegrate, right? Half-life period of the radioactive substance denoted by T to the base 1 by 2, right? So this have an idea. Now radioactive disintegration, let's see that half-life period, T to the base half, generally they will represent capital T, 0.693 by lambda. Keep in mind half-life period formulae. Lambda is decay constant. Then the most important formula is here. The radioactive sample, the number of nuclides undecayed after n half-life. Here n is number of half-life, that is represented by T by capital T. Capital T is half-life period. Small t is the time, right? Time period. How many years or how many days, whatever radioactive substance. T is the time period. Capital T is half-life period, half of its original atom to disintegrate. So n equals number of half-lives. So this is the formula, keep in mind. N equal to n naught into 1 by 2 whole power n, where small n equals, we know, T by T, and this n naught bring it down, n by n naught equals 1 by 2 whole power n. So this is the important formula, keep in mind before we proceed into MCQs, right? Let us start today's the radioactivity MCQ, the important one which appeared frequently, the similar model in all the competitive examination, right? Let us start the first question of radioactivity, right? Here it is. A certain substance decays 1 by 32 of its initial activity in 25 days. The half-life is, right? Question, try to understand clearly. A certain substance, a certain radioactive substance, right? A certain radioactive substance decays, emission, right? Radiates 1 by 32 of its initial activity, right? In 25 days. The half-life is, what is it? Half-life period. See, certain substance decay going on 1 by 32 of its initial activity. You just assume, right, 1 gram of this radioactive substance. 1 gram of this radioactive substance, right, has to become half-life. What happened? The 1 gram has to become half gram. What is the time required? That is half-life period. So first half-life, this 1 gram of radioactive substance become 1 by 2 gram, right? For first half-life, 1 gram become half gram. First half-life, half of its original atom to disintegrate. Okay. Now, after second, now 1 by 2 gram become half-life. Second half-life, this 1 by 2 gram becomes 1 by 4 gram, right? Clear? Now, third half-life, see that this 1 by 4 gram has to become half of its original atom. It become 1 by 8 gram, right? Then this 1 by 8 gram half-life, how much? Already 1 half-life, 2 half-life, 3 half-life, 4th half-life, right? If 1 by 8 become half, it will become 1 by 16 gram, 4th half-life, right? Next again, it is 5th half-life, 1 by 16 has to become half of its original atom. It becomes, see, 1 gram half is 1 by 2. 1 by 2 half is 1/4. 1/4 half-life is 1 by 8. 1 by 8 become 1 by 16 half-life. 1 by 16 become 1 by 32 in half-life. Sir, why do you going this half-life? First, how many number of half-life is taking? See, the half-life is, we know that formula, number of half-life, right? This is n is number of half-life, n equal small t, time period by half-life period, right? From here, we want only half-life period, right? Half-life period T, capital T equal T by that n, bring it down. What is the time given here? Time period 25 days. The activity, radioactivity going on for 25 days, right? By number of half-life, right? See, number of half-life. See, question is, a certain substance decays 1 by 32 of its activity in 25 days. See that we don't know how much the substance. That's why taken 1 gram. It become half-life. First one half-life it become 1 by 2 gram. Second half-life it become 1 by 4 gram. Third half-life it become 1 by 8. Fourth half-life 1 by 16. Fifth half-life it become 1 by 32. See the question? 1 by 32 of its initial activity in 25 days. That means how many half-life, number of half-life, n equal, right, 5. That is why from here what you understand, number of half-life in order to become 1 by 32 of its original, it takes how many half-life? 5 half-life. Now n equal to half, n equal number of half-life is 5 mean what is the original half-life? That is why n equal t by half-life period. From that half-life equal t by n. So time period 25 days. What is n? 5 half-life. So half-life period is 5 days. So the correct option is 3. Right? 3 is the correct option. I got it? Very simple. Certain radioactive decay 1 by 32 of its initial activity. So 1 by 32 of its initial activity in 25 days. A time period is given small t. What is the half-life? So we need to know what is the number of half-life this is. That is why we taken first initially 1 gram of radioactive substance. First half-life it become 1 by 2. Second half-life it become half of this. Third half-life it will become half of this. Goes on until you get 1 by 32. 5 number of half-life will be 5. So substitute, you will get 5. Let us go for the next one. Right? Here it is. A radioactive sample contains 600 radioactive atoms. Right? A radioactive sample, suppose plutonium, radium, thorium, anyone, initially before disintegrate, 600 radioactive atoms are available. That means n naught, right? Number of atoms present at starting initially before disintegration when t equal to 0, n naught, number of atom present 600, right? Then its half-life period is 30 minutes, right? Clearly is given. Its half-life period is 30 minutes, right? Half-life period is 30 minutes. Then the number of radioactive atom remaining, right? If the decay occurs for 90 minutes, what is the number of radioactive atom remaining? N is the question, right? So here when t equal time period how much is given? 90 minutes. When 90 minutes it go on decay, what is the number of atoms remaining? Undecayed. That is the question, right? We all know n by n naught equal, right, 1 by 2 whole power n. Here the small n we all know, small n equal to small t by capital T, half-life. Clear? From this n equal, right, you got it now. What is small t? 90 minutes, right? Small t is 90 minutes and by small t 90 minutes, capital T half-life is 30 minutes. So 0 0 cancel, 3 3. So n is how many half-life taking place? Number of half-life 3. So number of half-life 3. Now you can substitute n by n naught equal, right? This is, see here, n by n naught equal 1 by 2 whole power, number of half-life is 3. So 1 cube 1, 2 cube 8. So n by n naught equal 1 by 8. We need to find n, right? What we need to find? Number of atom undecayed. So from this equation, n equal n naught into 1 by 8. We know n naught, right? Number of atom before disintegration into 1 by 8. Now simplify, you will get 75, right? Number of radioactive atom remaining is 75 is the right answer. Right? Yes. Let us go for the next one. Right? The next question is, are you Unacademy Plus subscriber? There are more than 40 top educators on Unacademy Plus course and 10 plus batches, 250 courses and 2000 lessons every session is going on. Morning to evening, non-stop, right? Online coaching for PCMB. The benefit of Plus is affordable price, right? Structured live courses and live doubt clearing session. So everything, right, with a single subscription, unlimited access. So no need to wait. Use my code Vetrivel, subscribe Unacademy Plus and enjoy the learning, right? You will become topmost scorer in KCET and other competitive exam. So Unacademy is the ultimate destination for those who are looking for 2021 KCET and other competitive examination, right? Okay. Now let us move to next question, right? Now T half, that means half life for a radioactive nuclei is 12.5 hours, right? Then and its mass is 250 gram. The time after which an amount of remaining substance is 1 gram is, after how many hours this mass become 1 gram. So here mass is given, so we can go for mass related formula. Instead of n equal to n naught, we can go m equal to m naught into 1 by 2 whole power n. N is T by T, right? That's it. Now this is after disintegration, m become 1. 1 equal, what is m naught before start to disintegration number? What is the total mass? Right? 256. Before disintegration, 256 gram m naught. M is 1 gram equal 1 by 2 whole power T by, what is half-life? 12.5 hours. So capital T is 12.5 hours. That's it. Now you can see that this 1 by 256 bring down equal 1 by 2 whole power T by 12.5. Now 1 by 256 I can write in terms of, in powers of 2, right? It is 8 times, right? 8 square you will get it 256. So 1 by 2 whole power 8. Because I want to make both side, left hand side, right hand side base equal. That is why in terms of 2 I am writing 1 by 2. This will be T by 12.5. That's it. Now since bases are equal, exponents are also equal. Now equated exponent 8 equal to T by 12.5. That's it. From this T equal to cross multiply 8 into 12.5, you will get 100 hours. So the 256 gram of mass after disintegrate, after 12.5 hours radioactive nuclei, it become 1 gram when after 100 hours. 12.5 hours, this is 256 gram. For 1 hour, it will be 100 gram, right? We'll move to the next question, right? Here it is. The half-life of a radioactive substance is 13 years. The decay constant. So we all know half-life period formula, right? The half of its, the time for which the half of its original atom to disintegrate. Half-life period is 0.693 by lambda. Here lambda is a decay constant is the question. That's it. So decay constant equal 0.693 by, right, T, half-life, right? Here half-life is how much is given? 13 years. That years you convert into second. So 0.693. See the answer all per second. So half-life is, here is given the radioactive substance whose half-life is 13 years. 13 years convert into second. 1 year 365 days, and 1 day we all know 24 hours into 60 into 60, 60 minutes, 60 seconds, convert all, multiply 24 into 60 into 60, you will get 86,400 second, right? Simplify this, you will get 1.69 into 10 power minus 9 per second. Option C is the correct answer. Right? Yes. Let us go for the next question. Here it is. Half-life period of a radioactive element A is 10 hours. See here, a radioactive element A whose half-life is 10 hours. Okay. A certain time 2g of A has become 0.25 gram. That means after some time 2 gram of A becomes 0.25 gram. Right? If the same time 4 gram of B, another radioactive substance, reduced to 0.5 gram. Now what is the half-life period of B? The both radioactive substance is given, right? All they given mass is given here, right? So since mass is given, we can use the mass formula. First I am going to use for substance A. We know that m equal m naught into 1 by 2 whole power n. N is small t by capital T. Here mass of substance after disintegration, see, it becomes 0.25 gram. So m is mass of radioactive substance after disintegration, 0.25 equal to m naught. Initially it was 2 gram. See here, A, the substance 2 gram initially. After it becomes 0.25. So before disintegration it is 2 gram into 1 by 2 whole power T. What is the time? 10 hours. Right? Understand? So it is 10 hours by T. Capital T is half-life. So 0.25. Right? Bring it down now. These two. Right? 0.25 multiply by and divide both sides by 10. Right? It is equal 1 by 2 into 10 by t. This multiply and divide by 10, 100. You will get, right, 25 by 200. That will be 1 by 8. Right, that we can write as a 1 by 8. This is both side multiply and divide by 100. So 25 by 200 you will get 1 by 8. 1 by 8 equal 1 by 2 whole power 10 by t. Then this in terms of 2 I can write 1 by 2 whole power 3 equal 1 by 2 whole power 10 by capital T. Then since bases are equal, then exponent you can equate it. Exponent 3 equal 10 by T. Then half-life period T equal, right? Bring it down. Now what will get, right? So T equal 10, how much? So see here, the 30 hours. How many hours you will get to T here? Here, half-life period of the radioactive element A is 10 hours. So, half-life period is 10 hours. So, here you need half-life period is 10 hours means this is capital T is 10. Remember, half-life period is 10 hours. That's the meaning, right? T by 10. This also T by 10. Half-life period is 10. Is given, right? So T by 10. Now what happened? T by 10. Now small t equal 30 hours. Now go for second. Substance B. This is substance A. For other substance B, we can go for m equal to m naught into 1 by 2 whole power small t by capital T. Right? What is m before, right, after disintegration? It reduces to 0.5. So a mass after disintegration, before disintegration it is 4 gram into 1 by 2 whole power, right? How much is given here? See that small t half-life is Half-life of the B is the question. But time how much is given? Already. See here properly. Right? T is, already we got T is 30 hours. So T here 30 hours. Right? Small t equal to 30 hours. Already we got for A. Same we have to substitute here. Now 0.5 by 4. Right? Bring it 1 by 2 whole power. Right? 30 by half life. That's it. This multiply and divide by 10. You will get, right, 5 by 40. That is nothing but 1 by 8. 1 by 8 equal 1 by 2 whole power 30 by t. This can be written as in terms of 2 power 3 equal to 1 by 2 whole power 30 by 8. That's it. Since bases are equal, exponents are also equal. So 3 equal 30 by t. Right. Half life equal 30 by 3. It is 10 years. See the 10 hours. A is the correct option. Right? 10 hours is the half-life period of second one. Yes. Let us go for the next one. Next question. 3/4 of the active nuclei present in the radioactive sample decay 3 by 4 seconds. See, 3/4 of the active radioactive element, active nuclei present in radioactive sample. That means how much decayed already? 1/4. Right? The half-life of the sample is. So we know that n equal n naught into 1 by 2 small t by capital T. Here you see 3/4 of the radioactive nuclei present in the radioactive sample. That means then how much decayed already? 1/4 of the original. So n is 1/4 of the original radioactive element. Understand this, because 3/4 active nuclei present in radioactive sample mean then 1/4 is already decayed. So 1 by 4th of original atom into original atom by 1 by 2 whole power t by t. That's it. Now you can see both side n naught cancel it. You will get 1 by 2. We can write 1 by 2 whole square. That is equal 1 by 2 this side. You can. Right. That's it. Now bases are equal. Exponents are also equal. Therefore t by t equal to 2. From that half-life period t equal, right, bring it down, t by 2. That is, what is the time period is given here? 3 by 4 seconds. Radioactive sample decay in 3 by 4 seconds by 2. Right? 2 in the sense 1. So 3 by 4 into 1 by 2, you will get 3 by 8 seconds. This is the correct answer. Right? Yes. Let us go for the next one. Right? Plutonium decays with a half-life of 24,000 years. See, plutonium decays with a half-life clearly is given. Right? Half-life of plutonium is given clearly 24,000 years. Right? Next, if the plutonium is stored for 72,000, that means time period is given. Right? The plutonium is stored for 72,000 years. Right? Time period is given. What fraction of it remains? How much fraction it is remain? We know number of half-life equal t by half-life. Right? How much t time period? 72,000 by half-life is 24,000. So you will get number of half-life will be 3. So number of half-life 3 means, suppose 1 gram of plutonium, number of half-life 3 half-life. So 1 gram of plutonium in first half-life, it become 1 by 2 gram, right? Half of this atom to disintegrate. Now this 1 by 2 gram second half-life, this 1 by 2 gram become 1 by 4 gram. This 1 by 4 gram third half-life, because we got already number of half-life is 3. So 3 times you do the half-life. 1/4 become 1 by 8 gram in third What is that? In third half-life, how much fraction is left over? 1 by 8 grams. So the fraction, that's only question. What fraction is remain? So the fraction of plutonium remains. The fraction of plutonium remains is, right, 1 by 8 gram. This is the correct answer. 1 by 8 gram plutonium is remain, right? Yes, let us go for the last question. The half-life period of a radioactive substance is 20 days. Clearly understand, half-life period of the radioactive substance is 20 days. What is the time taken for 7 by 8 of its original mass to disintegrate? What is the time taken for 7 by 8 of its original mass to disintegrate? Original mass we don't know. So let the initial mass, right? Original mass we don't know. So let the initial mass be, right? You take it as 1 unit, right? Original mass is 1 unit. Now mass remaining, right? How much mass is remaining? Right, 1 minus 7 by 8. See here, what is the time taken for 7 by 8 of its original mass to disintegrate? So original mass we don't know, that we taken 1 unit. Then mass remaining will be 7 by 8 is disintegrate. So 1 minus 7 by 8, you will get 1 by 8. Right? Now we have mass of 1 unit. See that 1 unit mass, right, becomes 1 by 2 unit in first half-life. One half-life, 1 unit mass become 1 by 2 unit mass, right? Now, for second half-life, this 1 by 2 unit become in this half 1/4 unit, right? Now, this 1/4 unit mass become half-life. Third half-life, this 1/4 unit become 1 by 8th unit, right? So now what is the time taken here? You see, right? 3 half-life, actually number of half-life here. So to become 1 by 8, how many half-life is taken? 3 half-life. So number of half-life, right? Number of half-life is 3. So question is, what is the time taken for this, right? So the time taken is 3 half-life, keep in mind. So the time taken for 3 half-life, time taken for 3 half-life equal 3 into, what is the half-life is given? See the first line. The half-life period of a radioactive substance is 20 days. So 3 half-life taking place. So 3 into 20, it's taking 60 days. So it is the correct answer, right? What is the time taken for 7 by 8 of its original mass to disintegrate? It is 60 days it takes, right? That's the correct answer. So that's the end of today's session. Champion batch is in progress. Unacademy Plus. Learn from the best educator for KCET 2021. Detailed explanation for each topic for better understanding. Complete syllabus coverage is taken care. Tips and tricks to save the time and score better in exam. Right? Have a try. At least you can put a trial 1 month plan for 2250. It is affordable price. So you will get all the subject PCMB from topmost lecturer in Karnataka. Don't forget, use my code Vetrivel and subscribe Unacademy and you can crack Karnataka CET. Right? So with that, I am Vetrivel, Unacademy Plus Educator, signing off from you all. We will meet the next YouTube session with another important topic. Till then, have a nice day. Thank you.